Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 4 from the Smith Organic Chemistry textbook. And this problem gives us four IUPAC names and asks us to draw the molecules. Remember, when you see a problem like this where you're given the name and asked to draw the molecule, a good first step is always to identify the backbone or like the main chain. And so for A, we have 2-isobutyl, 3-isopropyl hexanol. And so hexanol tells us 6. So the backbone is a 6-carbon backbone. So 1, 2, 3, 4, 5, 6. We're also told in that name in hexanol, we know that there's an aldehyde. So we can put our aldehyde in. And so then we just fill in the rest of the information that we have. So if we make the aldehyde carbon number 1, we're told that there's an isobutyl group at carbon number 2. So put in our isobutyl group. And then we're told that there's an isopropyl group at carbon number 3. So we can go ahead and draw that in. And that's the answer to A. So then for B, we'll approach it the same way. So trans 3-methyl cyclopentane carbaldehyde. So cyclopentane carbaldehyde is the main part of this, or the backbone. So we need to draw a cyclopentane ring with a carbaldehyde on it. So 5-membered ring. So there's our cyclopentane. Carbaldehyde, we can draw the aldehyde there. And then we need to look at the rest of the information in this name. So it says trans 3-methyl. So we need to put a methyl group in at the 3 position. So to do that, we name the carbon with the aldehyde coming off of it. The ring carbon with the aldehyde substituent is carbon 1. So 1, 2, 3, and just get rid of those numbers, and then we'll put a methyl group there. And of course, we are told that it's trans, so we can go ahead and introduce stereochemistry there. So if we make that bond wedged, then the bond with the aldehyde on it has to be dashed. And of course, we could do it the other way as well. The name doesn't specify, it only says that they're trans. So we could also make the methyl group dashed and the aldehyde wedged. All right, and that's B. So then for C, the name that we're given is 1-methyl cyclopropane carbaldehyde. So again, the root, or the main part of the name, is going to be cyclopropane carbaldehyde. So we need to draw a cyclopropane ring. And then carbaldehyde. So there is our aldehyde. And then the rest of the name is 1-methyl. So the ring carbon from which the aldehyde attaches, or to which the aldehyde attaches, I suppose I should say, that's going to be carbon 1. So we'll just also put a methyl group on that carbon. And that's the answer to C. So then lastly for D, we have 3,6-diethyl non-anol. So non-anol tells us this is going to be a 9-carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, the anol tells us aldehyde. So There's our aldehyde. And then when we look at what else we have, it says 3, 6. So the aldehyde carbon is carbon 1 here. So we can count 1, 2, 3, and then an ethyl group, and then 4, 5, 6, and a second ethyl group. And so that's the answer to part D of this problem. And again, to solve these, remember, just identify the root or the main chain or the backbone chain, draw that, identify your substituents, and then put them in as necessary. And that's the answer to chapter 21, problem number 4.